In the case of vector-borne parasites, African governments have attempted to eliminate the vectors, the flies and mosquitoes and other insects that carry parasites for river blindness, elephantiasis, and malaria. These efforts have slowed the spread of some infections, but many scientists argue that eradication of parasites may not be possible.
We've actually never been able to control, to the point of extinction, any parasitic infection. The only disease-producing agent we've ever been able to get rid of is smallpox. And that's because smallpox only infected the human and no other host. Some of these parasites can infect multiple hosts. You can have reservoirs out there. So even if you could effect cures in people, you still couldn't get rid of it in the animal populations that might also harbor the same stages. So even if you could control everything in the human population, you could still reintroduce it every now and then because of these animal reservoirs.
If eradication isn't an option, then controlling the spread of infection is the answer to limiting parasitic outbreaks. One control success story is the onchocerciasis control program.
When onchocerciasis was at its height in the late 60s and early 70s, it became evident that this disease was a major impediment to successful development, particularly of these countries in West Africa where it was so highly endemic. Because of that, the World Bank, the WHO, and other international organizations banded together to form the Onchocerciasis Control Program, which has, in its 25 years of existence, had a major impact on blocking the transmission of the disease, protecting the vision of over 600,000 Africans in West Africa, and allowing somewhere in the order of 15 million children in this area to be able to grow up without the threat of blinding onchocerciasis.
The guinea worm story is one of our shining lights in terms of parasite controls. It's found throughout the tropics, throughout Africa, throughout the Middle East, throughout India, and even in South America as well. It's an intermediate host, that is, it lives in other things besides humans. It lives in this little water flea. And by filtering out the water flea, you can get rid of the guinea worm. And we taught people how to do that. They went and did it, and we've controlled this infection now in all but 13 countries throughout the world. It used to be in hundreds of countries.
In the developed world, new water treatment practices have been developed to keep out Cryptosporidium parasites. Milwaukee spent $80 million building a new water plant. But the tragedy in Milwaukee brought attention to the daily efforts being made on the part of water treatment officials to ensure that our drinking water remains safe.
The lessons that we learned in Milwaukee is you need to be prepared. You need to know the capabilities and the vulnerabilities of your water treatment system. One can never say this will happen again, but one can never say it won't. And so until there's assurance between the health department, the water officials, and others that you're as prepared as you can be, you're at risk.
David Leiby of the American Red Cross believes the Milwaukee outbreak was a wake-up call.
The sheer size of the incident suggests that there's a potential for this type of thing to occur in the future. I mean, even though our water supply, like our blood supply, is very safe as well, and great measures are taken to prevent these kind of instances or these kind of occurrences from happening. However, it just points out the fact that parasites can, in fact, be very opportunistic. And then if there is a possibility of them getting into a system, in this case a water system, which they are allowed an opportunity to grow and develop and to replicate, then they certainly can take advantage of it.
Some see a future in biological controls, putting parasites at war with each other. Introduce a benign echinostome fluke to the host of a parasite like the schistosome fluke, in hopes that the benign fluke will attack and kill its harmful cousin.
The snail is infected with this evil schistosome, and along comes this nice echinostome that has a mouth and a gut, and it seeks out the schistosome in the snail, and whammo, it sucks it up, it swallows it, and the schistosome larval stage is gone. This is a marvelous biological adaptation whereby this tug of war is going on in the snail, and the schistosome, this evil schistosome, is destroyed by this nice echinostome.